This is about radium-226. An initial sample of 100 grams decays to 99.956674 grams after 1 year. What is the half-life then of radium-226? So for its decay equation, the amount after time t given in years, is equal to the initial amount is 100 grams times e to the RT, where R is the decay rate for this radium-226. Now, after 1 year, we know how much is left, so let's make use of that. So the amount left after 1 year, which is 100 times e to the R times 1, when t equals 1, but R times 1 is just R. And we're told that after 1 year, it's decayed to, instead of 100, 99.956674 grams. Dividing both sides of this equation by 100, we get e to the R is equal to, well, dividing by 100 shifts the decimal place over twice, so 0.99956. Now if we take the natural log of both sides, or simply write this exponential equation in logarithmic form, either way we end up with natural log of e to the R is R, and natural log of 0.9995674. Now we know what R is, so we could next answer the question about what is this substance's half-life? So, we know the decay rate, and it's negative because this number in here is less than 1. So, how long before this decays to half of its initial amount? Since it was 100 grams, after t years have gone by, it'll have decayed to 50 grams. So we want to solve for t. How many years? Dividing both sides by 100, we get that e to the RT power is equal to 1/2. And writing this equation in logarithmic form, we get, or taking the natural log of both sides, that R times T is equal to the natural log of 1/2. This is just by taking the natural log of both sides, or writing that equation, the exponential equation, in logarithmic form. But anyway, we then find that T is equal to the natural log of 0.5, 1/2 is 0.5, divided by R. And this is the R. In other words, T is equal to the natural log of 0.5 divided by R, and that's the value of R that we just calculated. Let's calculate T then. The half-life of radium-226. So 0.5, take the natural log of 0.5 and divide that by the natural log of 0.9995667 and I get 1,599.49456. Anyway, rounding it off to the nearest year, So that's the half-life of radium-226.